Okay, so this is the office hours for assignment 5. You should have checked your answers already and try to fix them on your own, if at all possible. That's best case scenario. Here are all the answers. So we're just doing some conversions, and I guess we could use a calculator for some of these values. On my calculator. But that would be so. Let's do, and then 21 and 28 is really just some practice with that problems that we've been doing, but now with radians. And these you really should avoid converting to degrees. You got to figure out how to do it without degrees. And then on the back, we got some arc lengths and some other problems like that. So let's try these out. Okay, so give the exact radian measure, so no decimals. So the conversion factor is pi radians equals 180 degrees or vice versa. If you want to get rid of degrees, then you need degrees in the bottom to cancel out. You need radians on top. 45 goes to 180 4 times. So the answer is pi over 4. 90 degrees with the 180 on the bottom, pi on the top. Degrees cancel. 2, pi over 2. With the degrees on the bottom, 180 degrees, pi on the top. 60 goes in this 5 times, 60 goes in this 3 times, so you get 5 pi over 3. Okay, negative 180, you want 180 on the bottom, pi on the top. Get negative pi. 330, negative 330, so we're going to multiply by 180 degrees on the bottom, pi on the top. Definitely take a 10 out of both of those, and I think that's it. Or no, we can take a 3. 11 and 6, so it's going to be negative 11 pi over 6. Okay, 450 degrees, 180 on the bottom, pi on the top. Divide 10 out of both, take a 3 out, that would be 15, and that would be 6. We could take another 3 out, that would be 5. And 2, so it's going to be 5 pi over 2. Okay, 180 degrees, pi on the top, divide 10 on the top and bottom, divide a 9 3 times, 9 2 times, 3 pi over 2. Right, 180 degrees on the bottom, pi on the top, divide at least a 10 out of both, divide a 3 7 times, 6 times, 7 pi over 6. 180 degrees on the bottom, pi on the top. You divide, let's see, what can we divide? At least a 5, right? 5 would go into this 63 times, 5 would go into this 39 times, right? Every 10 is 2 5s, so I say, well, 18 tens, 36. 36 5s. I think we take another 3 out, that'd be 21 and 12. And we take another 3 out, that'd be 7 and 4. So I think we can get down to 7 pi over 4. All right, 180 degrees on the bottom, pi on the top. This goes in twice, negative 2 pi. So just some quick conversions, which honestly, we're going after this unit, we're not going to be converting. We're just going to be given radians and work radians. And these we're going to convert to the nearest degree. So this is radians already, so you want radians on the bottom and degrees on top. Those go away. 4 goes into this 45 times, so it's going to be 3 times 45, 135 degrees. Well, pi 180, 180 degrees. So these are coming out nice anyways right now. Pi on the bottom, 180 degrees on the top. Pi's cancel. 6 goes in this 30 times. So it's going to be 33 with an extra 0 degrees. Okay, pi on the bottom, 180 on the top. Pi's cancel. 12 goes in this 10, 15 times. 7 times 15, 70 plus 35 is 105. Okay, pi on the bottom, 180 on the top. Pi's canceled, 4 goes into 45 times. It's going to be negative. Every 2 45s is 90. So 90, 90, 180, 360, and then another 45 would be 405. Okay? Now, these ones don't have pi's, even though they're radians, and so they're going to end up with pi's in the answer. So we'll go ahead and get the exact answer first. So that's going to be 360 over pi degrees. Now, on your calculator, you could just do this on your calculator and say, okay, well, 360 divided by pi is 114.6. Now, I said to the nearest tenth, which means 1 decimal accuracy, and you have to round. Nearest means rounding. So just throwing a little curveball there for you. Usually it's 3 decimal accuracy round truncated. 180 over pi. That's going to be 360, 445, 40 over pi degrees. And on a calculator, it's going to be 171.9 degrees. Times 180 over pi. A fourth of 180 is 45 over pi degrees. That's exact. On your calculator, it is 14.3 degrees. So I'm looking for this work right here. We're showing conversions. 180 over pi. 0.3 of this is going to, if on your calculator, you get 5.4 over pi degrees, which is 1.7 degrees. And the last one, 180 over pi. 1.5 times this would be 270 over pi degrees. As a decimal, 85.9 degrees. Nearest tenth. There you go. Now these problems, what I'm really going to challenge you to do is you could convert, but you really don't have time to. So the only way you're going to get good at radians is if you force yourself to do radians. If you lean on conversion to degrees as a crutch, you are not going to get better at radians. You're not going to have time to finish your tests. You're going to be making lots of mistakes in your conversions too. So here's the way to remember it. Remember the values. There was 0, 30 degrees, 45, 60, and 90. Now, I just memorized those on their own. Okay, and then the values for sine and cosine, for sine, it was 0, 1/2, root 2 over 2, root 3 over 2, and 1. Now, these values are the same. We're just memorizing some angles that go with these. So instead of 0, 30, it's 0, pi over 6, pi over 4, pi over 3, pi over 2. Now, the bigger the denominator, the smaller the angle. So it makes sense that the earlier ones have bigger denominators. And, pi over 6, it skips pi over 4, pi over 5, pi over 4, pi over 3, pi over 2 is the biggest of these. So memorize these and these now. Memorize these on their own, memorize these on their own, memorize these on their own. There's 3 different sets of values that if you memorize them separately, then you could connect these to these just like you were connecting those to those. So I say, pi over 3, it's 0, pi over 6, pi over 4, pi over 3 is the bigger angle, right? So that's 0, 1/2, root 2 over 2, root 3 over 2, and it is quadrant 1. Done. You just got to memorize these. And pi over 4 is easy because that's 40. That's the same as 45 degrees. That's the same for both of them. Root 2 over 2. Pause. Okay, tangent of pi. I don't memorize tangent values. I memorize sine and cosine values. Sine of pi. Pi is the same as a half circle, right? It's right here on the sine curve. Sine it's halfway through the period. Sine is 0, cosine is 1. The answer is 0. Okay? Negative pi over 2. Now, that's the same as one quadrant. If it's 2 pi, then each quadrant is pi over 2. Pi over 2, 3 pi over 2. Each quadrant is pi over 2. So that's a quadrant. Same thing as like 90. That's going to be 1, but we're going backwards, so it's going to be -1 because it's going into that. It's right here. It's hitting that one. It's going backwards right here. Okay? 5/6, that's a small angle. And for cosine, that's √3/2. Now, going negative means you're going backwards, but it's going to be a positive answer because, envision the cosine curve. If you go backwards into quadrant 4, it's positive. 5/6, alpha equals pi/6. So I'm going to be doing the alpha stuff still, okay? That would get you to pi, right? This is pi. 5/6 is right here. It's not quite pi. It's pi/6 away from it. That's your reference angle right there. So you'd say, well, cotangent, first of all, is tangent upside down. So it's going to be cosine over sine of essentially pi/6, pi/6. Now, cosine pi/6 is √3/2, and sine of pi/6 is 1/2. But we are in quadrant 2. So cosine is negative and sine is positive. So the final answer is going to be -√3. Just -√3. Okay? Secant is a reciprocal trig function. So that's the same thing as 1 over cosine, co with a non-co. Now, the reference angle is pi/4. And it's in quadrant 2. Cosine of pi/4 is cosine of pi/4 is √2/2. In quadrant 2, it's negative. So it's going to be -2 over √2. So it's going to be -2 √2/2. So it's going to be -√2. Simplified. Cosecant is 1 over sine, right? 1 over sine. Reference angle is, well, this is, if you can imagine it, pi/6 is 6 pi/6 is here, so it's 4 more pi/6. So I think we're here. I mean, by the way, this is the same thing as 5 pi/3. That might be easier. So this is 5 pi/3. 3 pi/3 gets you right here. And this is 2 more pi/3. So it's pi/3 is the reference angle. And we're definitely in quadrant 4. So this is the bigger angle. It's a bigger angle. Pi/6, pi/4, pi/3. So for sine, the values are getting bigger. 1/2, √2/2, √3/2. You're in quadrant 4, so it's going to be negative for sine. So it's going to be -2 over square root of 3. So it's going to be -2 √3/3 for your final answer. Okay? You got to get used to radians. You just have to get used to radians. You can't rely on converting. That's going to take too much time. So, all right, now onto the back, little circle stuff. So let's see, little circle stuff. So on a circle of radius 24, find the length of the arc. Now, don't memorize those arc length formulas. I guarantee you're going to memorize them wrong. You're going to forget them. Remember the basic idea that the central angle over the angle of the whole circle, 360 degrees, or in other words, if it's in radians, it's over 2 pi radians, but it looks like we're dealing with degrees, equals the arc length, which we often use a little s for, over the arc length of the whole circle, which is circumference 2 pi r, equals the area of the sector, the piece of pi, over the area of the whole circle, which is pi r squared. Now, we're really just going to rely on these two together. So theta. Okay, so that's what we're going to be using. We're going to say, okay, well, arc length equals circumference 2 pi r times theta over 360. I think we might use the other version too, 2 pi r times theta over 2 pi, which simplifies down to r theta for radians, which I think are going to be these ones, right? If they don't have a degree symbol, that must mean they're radians. So for this one, the arc length, I'm not, like I said, I'm not trying to memorize this formula. I'm going to recreate it. And so it's going to be 2 pi r is 24 on here, 24 times 60 over 360. So that's going to be 1/6. And so that's going to be 6 goes in that 4 times. So that's going to be 8 pi inches. There are units, so you got to do inches. And then let's go ahead and I guess we're going to go ahead and keep going with the 10th. Well, I don't know. We'll do 3 decimal accuracy. Not that it says to do that. So you could just give me exact. But that's your answer. So this one's going to be times, it's going to be over 360 times 2 pi times 24. So we get divided 10 out of the top and bottom. You divide 12 out of the top and bottom. You divide a 3 into that. So you have 5 times 2 is 20 pi inches as a decimal. It's 62.832. All right, next one, over 360 times 2 pi r. So you can divide a 60 out of this and a 60 out of this, and then you can divide a 6 out of this 4 times. So you have 2 times 4 is 8, times 5 is 40 pi. Don't lose the pi. Equals 125.664 inches. Okay, now these is radians. So we're going to do it over 2 pi radians times 2 pi r, and the 2 pi's cancel each other out. And then 6 goes to 24 4 times, so it's going to be 4 pi inches, or 12.566, 3 decimal accuracy. So this one's going to be 3 over 2 pi, but then it's going to be times the circumference 2 pi r. So the 2 pi's cancel, and you get 3 times 24 is 72 inches exactly. So little arc length stuff. This one says, what is the radius of a circle on which an arc 18 feet long subtends a central angle of given measure? So this is a central angle. This is theta. This is the arc length, and we're trying to find the radius. Okay, oh my gosh. Okay, so we're trying to find the radius. So I would go back to that basic relationship. Theta over 360 degrees equals theta over 2 pi equals the arc length over the circumference 2 pi r. So if we use these, if you have degrees, you're going to use these two. And you're going to be like, well, I want to solve for r. So that means that you might think, well, I could flip both sides upside down. If it's degrees, and then I could solve for r by multiplying by 2 pi over s. So I guess we could do that. So we could say, okay, well, r is going to be 360 degrees over the angle, 120 degrees, times 2 pi over 18. So we just got to simplify that. That goes in 3 times, that goes in 6, that goes in 3. R equals, oh no, I feel like I messed this up. Okay, let me start over again real quick. This is the basic relationship. It's always going to be true. There's the radius. If I flip both sides upside down, multiply by 2 pi over s. So that's 3. Goes in. No. I don't know. Let's see the next one. Now the next one's in radian. Okay. Well, you know what? Here's the deal. This is arc length, right? Let's do a little different, as if we were trying to find arc length. Arc length is 18. So arc length is 18 equals 3 pi over 2 pi times the circumference 2 pi r. Okay, 2 pi's cancel. I'm going to solve for r here. So r is going to equal 18 times 2 over 3 pi. And r is going to equal 12 over pi feet. And then as a decimal, that's going to be 3.8200. So let me go back over here. New strategy. If the arc length is 18 and the angle is 120 degrees over 360 degrees, then it's going to multiply the circumference 2 pi r. Now that's going to give you 3. So we're going to end up multiplying. R is going to be 18 times 3 over 2 pi. That goes in there. So R equals 27 over pi. Feet, as a decimal, is 8.594. So I don't know. My initial strategy wasn't working well. It seems like it should work or it could work, but I was messing something up. So I'm not going to. It's fine to call it quits and take a different route. So arc length is 18. And the way we would find it is we'd say, well, this angle over 360 times the circumference 2 pi r. Well, that's just 1. So r is going to equal 18 over 2 pi. R is going to equal 9 over pi feet. As a decimal, it is 2.865. Okay, the arc length is 18. Pi over 2 pi times 2 pi r. Those cancel. R equals 18 over pi feet. As a decimal, it is 5.730. So that's the strategy. Okay. Last problem. What is the speed of an Earth satellite traveling in a circular orbit at an altitude of 600 miles if it completes an orbit in 80 minutes? Answer in miles per hour. And something to help you. The radius of Earth is about 4,000 miles. Let's draw a picture of this. We're going to start to see coming up soon. Drawing pictures is going to help. So radius of the Earth is 4,000 miles. The satellite is in an orbit at an altitude of 600 miles. So that's above the Earth's surface. That's altitude. So here's the satellite. Okay. And it says that it takes it 80 minutes to orbit it. So we can figure out the arc length of the circumference. We want to find the circumference of this 2 pi r. The radius is 4,600 miles, right? So that's going to be 9,200 pi miles is the circumference. So if it takes it 80 minutes, speed is, speed equals rate time or I guess you could think of distance equals rate times time. You guys remember that? D equals RT. So you can use that to find the rate. So rate equals distance over time, which kind of makes sense. Miles per hour. The distance is 9,200 pi miles. The time is 80 minutes, but we want miles per hour. So we got to change our minutes to hours. So that's 60 minutes in an hour. So it's going to be 9,200 pi miles and over 4/3 hours. So we could get an exact answer here. If 4 goes into 92, 46, 23, and then gets multiplied by 3, so that's 6,900 pi, exactly, miles per hour. On your calculator, it's 21,676.989. So there you go. Something make you get a little creative. That's it.